Okay, we are on our last example for this lesson. Now, if you haven't already done so, I want you to pause my video and I want you to attempt this problem on your own. Use the example that I just did to try to do this problem. You should not be just watching me do it every single time. You guys need to put in the practice and try the work and then check your work based off of my explanation. So if you haven't already tried this problem, I want you to pause my video and try it now. If you have attempted this problem already, now you can go ahead and watch the video to see if you did it correctly. So I'm interested in finding out what type of AP test preparation is best for you guys to be successful on the AP Statistics exam. So what I did is take a random sample of 149 students who passed the exam and a separate random sample of 101 students who did not pass the AP exam. And I asked them about their test preparation. How did you prepare? There were 3 different responses. Some used a test prep book, some just had my review, and some did none, no review at all. So that's kind of the two-way table that I came up with. Now remember, in order to do a chi-squared test, we want to compare the observed counts, what we got from our sample, to the expected count. So what we need to have is our totals. Okay, so there were 50 people that used a test prep book, 100 people that had my review, and 100 people that did no review. So out of that, that's a total of 250 people that I sampled. That's my grand total, okay? Now, out of the 250 people, 149 passed the test, and 101 did not. So we've got our totals in here, and those are going to help us with our expected counts. I know I'm going to need these later, so I'm just going to do it now. So I'll go ahead and put in the work for this one, how to show you expected counts. Now remember, we take the row total times the column total, and we're going to divide by the grand total. So for this one, I'm going to do 50 times 149, and I'm going to divide by the grand total of 250. That gives me an expected of 29.8. That's how many people I would expect to pass, assuming there's no difference, okay? If I did the next one, it'd be 59.6, and the next one would also be 59.6, because on both of those, the row totals are 100 times 149 divided by 250. Okay, over here, the expected count ends up being 20.2. This one ends up being 40.4 and 40.4 again, because again, these are going to be the same work, okay? Now, I know I'm going to refer to these later on, so I'm going to go ahead and label these, that these are my expected counts. That's what I would be expecting to see if I'm assuming that there's no difference between the test preparation, okay? So my question is, does the data provide significant evidence that the success rates are different depending on the type of test preparation? Well, if you look at this, I mean, honestly, I would think that if you put no work into preparing for this AP exam, I would assume that that has an effect. Maybe not so much of a difference between mine and the test prep book, but I want to know, is there enough evidence to show that the type of test preparation will determine whether or not you pass the test? So what I have to do is I have to assume that there is no difference, okay? So here ends up being my alternative and my null. My null hypothesis is the success rate is the same for each type of prep, whether you used a book, my review, or none. I'm assuming that you guys are going to have the same success with all of these. You might have noticed I put P1 equals P2 equals P3. So what I'm basically saying is the proportion of all of those types would be the same. The proportion of those who did the test prep book would be same as those who did my review, which would be the same as had no review at all. Now remember, this is our null hypothesis. This is what we have to assume because we're trying to show that it's not the same. And honestly, I would think it's not, because if you did no review, I'm thinking you're probably not going to have as much success. Okay, so like always, we need to put our alpha level. Let's put an alpha level of 0.05. Now, because we're technically comparing two samples, a yes and a no, those are the two separate samples, we have to put in our plan. Our plan is the chi-squared test of homogeneity, because we're comparing the two samples, and then we check our conditions. So you guys should already know the first one is random, and again, because I'm checking two samples, I have to talk about both. Random sample of students who passed, and we did a separate random sample of students who did not pass. So notice I mentioned both samples were randomly taken. All right. 10% condition. I did it for both samples again, assuming 149 is less than 10% of students who passed the exam, and assuming 101 is less than 10% of all the students who did not pass the exam. I put the word assuming in here just to be safe, because we may not know where Mrs. Blair is getting all of these samples from, so we might not know the entire population, so I'm just kind of putting assuming these numbers are less than 10%. But again, I did it twice, one for each sample. Now the large sample size condition, all expected counts are greater than or equal to 5. And we know that because we already looked at the expected accounts. So I'm going to say C above. So if you could look up here, every single one of our expected counts is greater than or equal to 5. So we have met the large sample size condition. Okay. The due portion, hopefully at least this part you guys can do okay because we've done so many of these already. It's a skewed to the right distribution. Chi-squared with the degrees of freedom of. Now this part might have been a little bit tricky. Go back to your chart and use the example I gave you. Chop off one row, chop off one column, or this is the row, this is the column. Count how many you have left. 1, 2 left. So that's a degrees of freedom of 2. Okay? So now we need to know the chi-squared value so that we could figure out the p-value. So chi-squared is equal to the sum of the observed minus expected squared over the expected. All right, and I showed you guys again how to do this quickly in the last video by typing them all into your calculator. So you can go back to the last video to watch it if you have to. I'm going to write down a couple of them. 40 minus 29.8 squared divided by 29.8. So that's the very first one for those who passed with the test prep book. And then I'm going to go ahead and I like to go down the columns. So now I'm going to go to the Blair review. 99 minus the expected of 59.6 squared divided by 59.6. And I don't want to write them all out, so I'm going to say plus dot 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 plus the very last one, which is 90 minus the expected of 40.4 squared divided by 40.4. So if you put all of the observed in list 1, all of the expected in list 2, and you make list 3 do the calculations for you, if you did that in your calculator, which I actually realized I did not do this ahead of time in the calculator, so I might as well show you guys what to do. So these are actually from my last problem, so I'm going to clear all those lists out, and I'm actually going to just do it after all. So 40, 99, 10, those are all the people that passed, and then 10, 1, 90, those are the people that did not pass. I'm going to put in my expected 29.8, 59.6, 59.6, 20.2, 40.4, and 40.4. Okay, so I'm going to have my list 3. Remember to have it up in list 3. You have to have this part highlighted for the formula to work. So list 1 minus list 2 squared divided by list 2. Observed minus expected squared divided by expected. So those are my values. I'm not going to write down the full decimal values of those, but I'm going to at least round them a little bit. Okay? So I'm going to copy those numbers down. The first one is 3.5, actually 3.49, plus 26.05 plus 41.28 plus 5.15 plus 38.43 plus 60.90. All right. So that's my chi-squared. In fact, I'm going to show you one more trick while I'm at it. You may not want to add all those numbers up because that could take a little bit. So here's my little quick trick. I noticed that these are all my chi-squared values. So what I could do is I could hit stat, and I could scroll over to calc and do one variable statistics on list 3, because list 3 is where my chi-squared components are. Now, I don't actually need all of those, but what is helpful to me is this one here. This is the sum symbol, the sum of the x's. That's the sum of every value in list 3. So that actually adds them all up for you. So my chi-squared is quite large, 175.3. Okay, so you can double check my work there and add those values, but it adds them all for you, 175.3. Lastly, we take our chi-squared test statistic and we plug it in for the p-value. So we need chi-squared CDF because that's where my chi-squared is, 175.3. And I think you guys can already see that the chi-squared is pretty large. So the chances of getting something that far off are probably going to be quite small. So our lower bound is the 175.3 with an upper bound of 999, degrees of freedom of 2. Let's go ahead and label those. And when you type it in, you do indeed get a very, very small number. I'll show you one more time on the calculator. I'll do it in this one. Actually, I'll do it in both. Okay, so we have a lower bound of 175.3. An upper bound of 999 with a degrees of freedom of 2. All right, so take a look at that. What does that mean? 8.59, all those numbers, e to the negative 139. Well, the fact that it's e to the negative 139, that's pretty much 0.000000. There's 38 zeros before you get to the 8. So that's pretty much 0. Okay, so hopefully you guys could probably see that already. It's going to be about 0, which is our p-value. It's highly unlikely to get a chi-squared that large. So that leads us to our conclusion. Okay. Assuming the null hypothesis is true, that the success rate is the same for each type of prep, there is a 0 probability of obtaining a chi-squared value of 175.3 or higher, purely by chance. This provides very strong evidence, because it's so small, against the null hypothesis and is statistically significant at alpha equals 0.05, because 0 is less than 0.05. Therefore, we reject the null hypothesis and can conclude the success rate is different depending on the type of test prep. So now notice I have one more sentence in here. I have my follow-up. The largest component of chi-squared was, look up here, look at the list, 60.9. Because the students who did not pass the AP exam with no review was much higher than expected. If you go back and look up here, okay, those that did no review, according to our expected, we would expect only about 40.4 to not pass, but 90 did not pass. So that number was a lot higher than what we expected. So that's the largest reason for the difference. So what I'm basically saying in this conclusion is the type of test prep makes a difference. So you could kind of look up here and see what's the smallest one, and that would probably, actually this one seems to be the smallest one. So it kind of gives you a better idea of, well, maybe not necessarily the smallest one, but these values can kind of tell you where your test prep is probably going to be best at. All right, so I hope, again, that you attempted this before watching my video, and that you just checked your work through this. I hope these videos have been helpful. Again, feel free to text me through Remind. I'm just at home, probably looking at the baby, if I've had the baby. And I'd be happy to answer your guys' questions through Remind. So feel free to let me know. Have a good day, you guys.